Welcome to Learn Fast tutorial. If this is your first time of seeing my video, consider subscribing, follow my page, please like and share this video to your friends. In this tutorial, we are going to talk about rationalization of surds. We are going to see how we can rationalize surdic expression. We have this problem on surd. If a is equal to 2 plus root 5, find the value of a minus 1 over a. So in order to solve this problem, remember that a is equal to 2 plus root 5. So anywhere we find a, we substitute 2 plus root 5. Now a minus 1 over a will be equal to, now we have a and we know a is 2 plus root 5, so we'll have 2 plus root 5 minus 1 over 2 plus root 5. So now we need to subtract these two expressions here. So we are going to use the LCM system, and then we know there's an invisible one here. So if we take the LCM of these two, this is the LCM. LCM is 2 plus root 5. And then subtracting these two, this divided by this, 2 plus root 5 divided by 1, we'll have 2 plus root 5. So we'll multiply by the numerator. So we'll have 2 plus root 5 into 2 plus root 5. And then 2 plus root 5 go in 2 plus root 5. In division, we'll have 1 times 1. So we're left with 1. Good. And now we are going to open the bracket. We are going to open this bracket. So we are going to multiply across. Now we'll have 2 into 2. We have 4 plus. Now we'll have 2 into root 5. So we'll have 2 root 5. And then 5 into 2, we have plus 2 root 5. And then 5 into 5 will give us, root 5 into root 5 will give us 5. I mean, we can prove that with indices, because root 5 is more like 5 raised to the power of 2. So if this multiplied, we know they have the same base, so we can actually add the power. Half plus half is 1, and 5 raised to the power of 1 is 5. So we've just proved this. So anytime you are multiplying with the same, when you have roots, you are multiplying roots, the roots will automatically cancel out. So that's why root 5 into root 5 will give us 5. And then divided by 2 plus root 5. Good. So from what we have here, then also remember to add your negative 1 here. And then if we evaluate what we have from the numerator, we'll have 4 plus 5, which is 9 minus 1, which will give us 8. And also, very importantly, we have 2 root 5 plus 2 root 5. Now, because we have the same roots, we can add these two expressions. Because they are of the same roots, I mean root 5 and root 5, so we can add these two expressions. And in addition, we're only adding the coefficient, which is 2. We don't add up the roots, we add up this, right? So now we have 8 plus 4 root 5, and then divided by 2 plus root 5. So this is what we have now. So this is where rationalization comes into play, because we still have a surdic expression in the denominator. So we can't just leave this thing like this, yeah? We can't just leave this expression like this. So we need to rationalize this in order to get a simpler solution to this problem. So if we rationalizing, we are going to multiply by the inverse of the denominator. We have positive root 5, but we're going to multiply by the inverse of this expression down. So we have 8 plus 4 root 5 divided by 2 plus root 5. So we're going to multiply up and down by the inverse of this. So we have 2 minus root 5. It's against plus root 5. And then also times 2 minus root 5. Good. So we're going to multiply across board. And you must permit me, we'll have 8 into 2, we'll have 16. 8 into negative root 5 will give us negative 8 root 5. And then 4 into 4 root 5 multiplied by 2. Remember, we're not multiplying what is inside of the root. We are multiplying the outside. So we have plus 8 root 5. And then 4 root 5 times minus root 5. The root will cancel out, and then we are left with 4 times 5. Just like what I did explain here. So we have minus, because of this minus sign, 4 times 5. Then divided by the product of 2, we have 4. And then minus 2 into minus root 5. We have minus 2 root 5. And then we also do have root 5 into 2, give us positive 2 root 5. And then root 5 into root 5, in this case negative root 5. So we'll have the root will cancel, we're having 5 remaining. Now remember, we can actually cancel out some things here, right? We have negative 8 root 5 and positive 8 root 5. So both of them can add to 0. This will add to 0, and also the same thing apply here. This will also add to 0. So we are left with 16. 4 into 5 is 20, minus 20 divided by 4 minus 5, right? So this and this will give us negative 4 over negative 1. And if we evaluate this, minus will cancel minus. So we are left with 4, right? So this is the correct answer to this problem. And this is how rationalization of surd is being done. It's quite simple and understandable. I hope you did enjoy the video. Make sure to like, comment, and subscribe to this channel. Share this video to your friends. Hope to see you on my next class. Thanks for watching.